So overall, as expected, of course, you did a great job. I'm just going to give you a couple of notes. The signs for inflammation um, look good. Just remember, heat is localized heat, and I would specify that. So localized at the tissue, not a systemic rise in temperature. Um, that leakiness of the capillaries is caused by histamine, and all the rest of that look good. Yep. The bradykinins are released from injured cells, and substance P is the neurotransmitter that allows the neuron to get that signal to the brain. Let's to get the pain signal to the brain. So the release, I think I just explained this part about why you weren't entirely sure the body releases those. Um, And yes, the fifth sign that you don't have here, and this is, something kind of new to separate this out, is that the pain often leads to immobilization of a joint if it's a joint injury, and that's to prevent further damage, which is what you put here so that you'll use it less. And being cognizant of the pain also helps us guard that site of injury as well. So for number three, I think you make a good point. That wasn't what I was aiming at. So I was thinking of, and I talked about this in the other recording, the tutoring session, that if a person gains weight through something like Cushing's disease or just rapid fat gain, then you have to have neovascularization or angiogenesis into that new tissue, and that is going to cause more peripheral resistance because the blood vessels get longer and you get more blood vessels, which will increase resistance, the peripheral resistance to blood flow, and the heart has to compensate by increasing blood pressure. So number four looks super thorough. The only thing I will add for you is down here where you said you thought there might be other worthy reasons. So if you consider someone who is immunocompromised, like a baby that might have SCID or a person that has AIDS, if they have a lesser adaptive immune response, that fever, taking the fever away by medicating it, is also taking away an innate response that's pretty powerful. So that would be the other reason not to medicate. So number five, you have the right idea. The lag time again is much shorter in the secondary immune response, but you should also add in here that, and I went through this in the tutoring video, so this will just be a reiteration of what I said there, that when you go through that primary immune response, you also, sorry, someone just texted me, you also have more of those antigenic determinants that are recognized by B cell antibodies and by helper T cells. So the secondary response is stronger and there are more antibodies made because not only are there just a higher number of antibodies made, there are more types of antibodies in higher numbers that are made. There's also more types of helper T cells that are specific to that antigen you saw the first time. And then timing, you've already written in there. And if I didn't say this, the antibodies again are more specific because you're recognizing more of those antigenic determinants. So number six, all good. And number seven, I went over in the tutoring session too, but it looks like you got most everything that I talked about. And then for number 8, there is some more detail that you need to put in here. So this question was meant for you to make sure that you understand every aspect of where the lymphocytes are born, which is in the red bone marrow, and then that the T cells are right? Gain immunocompetency and MHC restriction, which is also called self-tolerance, in the thymus gland. And, right, so you'd have to add here, like, where does activation take place? So when the CD4s and the CD8s leave the thymus gland, they're considered immunocompetent but naive. So that means they show self-tolerance and they are displaying specific receptors for specific pathogens. Whether those are the right receptors, it's kind of a matter of chance, and you'll figure that out later. So the later, which is the antigen challenge, takes place, and hopefully you can see my cursor right here so you know where it goes. The antigen challenge takes place in the secondary lymphoid organs, which would be not thymus and not bone marrow. And in those places, the T and B cells and the in this case, the T cells that are CD8s and CD4s, hang out in those lymphoid organs and wait for antigens to come find them, basically. The other thing you'll want to go through here, and this was also in the tutoring video, is that T cells require a co-stimulatory molecule or a co-activation molecule to make sure that it is 100%, as much as possible, 100% properly programmed. And then the cloning part, let's see. So you have, for differentiation, that looks good. The only other thing you want to add for both CD4s and CD8s is that you can have memory CD4s and memory CD8s. And I think that covers all of it. I think. So hopefully that answers all your questions. Again, I'm so sorry it took me so long to get back to you this week.